So good morning, learner, and welcome to today's lesson. Our math lesson is going to be conversion of fractions to decimals. Now I want to take you back to class 5 where we did equivalent fractions. Because what we are going to do, we are going to do it in two methods, and one of the methods was learned in class 5. Like for example, you can be given what we call equivalent fractions. And equivalent fractions, like for example 3 or 4, and then this is given at 12. So you ask, what is number y? What number is here? For you to get this number which is here, you just multiply this with this one, you get 4y is equals to 3 times 12, which is 36. Then you divide here by 4, you divide here by 4. So our y is equals to 9. So this number here is equivalent to 9 over 12. If you divide, you simplify 9 over 12, you go back to 3 over 4. Divide here by 3, you get 3. Divide here by 3, you get 4. So 9 over 12 is equivalent to 3 over 4 in that case. I know we did not use this method in class 5, but we can use now the method that we use in class 5. 3 over 4, then here 12. You ask yourself, what number do I multiply with 4 to get 12? The number is 3. So whatever I multiply here with here, I also multiply here with. So 4 times 3 is 12, 3 times 3 is 9. So that's why we're getting 9 over 12. So this method is going to enable us to be able to divide or convert fractions to decimals. It can also be asked, for example, can have 5 over 20. If you have 5 over 20, we want to get a number that all these, it has a one digit, 1 as a whole, and zeros. So what number what do we do to this number to get a digit 1 and the others are zeros? If you try to multiply this by 5, you will get 100. A digit 1 and the others are zeros. Even if it's 1 and the others are 3 zeros, it means 1,000. But we don't want a digit that is more than 1 here, and the others we want them to be zeros. So we have multiplied here by 5. So the equivalent fraction of this, one now, what we've done here, we also do here. Multiply by 5, you get 25. Now after getting this, the equivalent fractions of 5 over 20 is 25 over 100. From there, Anna, remember what I taught you when you beginning to this chapter? From there, you divide. This one point is there. We want to convert 5 over 20 into a decimal by number 1 using the equivalent method. Equivalent method. You have two methods you are going to use there. Number 1 is equivalent method, whereby if 5 over 20 can be written by looking at the denominator. We want the denominator to look like 1, to have one digit and the other numbers to be zeros. So that's what we have done, the conversion. From there now you divide. So the decimal point is there. It's supposed to move backwards 1, 2. Remember what I told you? When you're dividing with zeros, the decimal point moves backwards. So how many times? 1, 2. Equal number of the zeros that we have. 1, 2. So that is going to be 0.25. So 5 over 20 is simply 0.25 in decimal as a decimal. Let's see whether it's true. We are going to do that in another method and see whether it's true. So having done that, let me do another example using the equivalent fraction method. 3 over 8. Convert 3 over 8 as a decimal. Now, we are using equivalent method. What number do we multiply here with? To get a number with 1 and the other digits are zeros. Let's try. By 5 you get 40. By 15, by 10 you get 80. We don't want 80. So what number can we multiply this with? 8 by 25. Let's see here 25 by 8. 0, 34, 16, 200. We want 200. So that is by 25. What about by 20? You get 160. So that cannot apply in this method, and that's why I want to teach you another method, number 2, which is simpler for you. So this one is not going to make us get this answer. It's only going to choose some questions, and others are going to be very hard for you to calculate. So I want us to use now the second method, which is called the division method. Division method. So I want you to find that it's difficult to use equivalent method because sometimes you give it a number and you cannot get exactly what you have to multiply with to get an equivalent fraction. Now, this division method is what I've taught you even in class 6 and in class 5. We are going to begin with this question here. Convert 5 over 20 as a fraction. So fraction as a decimal. Remember I told you something like ND. The DN. The DN means when you're dividing, the denominator is supposed to be outside and the numerator is supposed to be inside. So in this case, the lower number is called the denominator. So you're going to put 20 outside and 5 inside there. So from there, we are going to see that 20 cannot be divided by 5. So you need to put 0 point and add a 0 there. And therefore, you're going to ask yourself, how many times do 20 get to 50? 2 times land. You get 40. So subtract, you get 1 0 there. You continue because you don't want to write this as a fraction. You continue. You add a 0 here. You ask yourself, but 20 gets to 100. Yes, how many times? 5 times. You get 100 there. And so your answer becomes 0.25. So 5 over 20 as a fraction, as a decimal is 0.25. Let's have another number. That is the number that we are doing. That is 3 over 8. We're going to be 3 over 8. So the denominator outside, the numerator inside. And so we're going to ask ourselves, can 8 be divided by 3? No. So it gets into 3 0 times. And then we add a 0 there. Now, can 8 be divided by 30? Yes. 8 gets into that 3 times. You get 24. You subtract, you get what? You get 2, 10, you get 6. Add a 0 there. Can 8 get into 60? Yes. How many times? 7 times you get 56. Subtract, continue subtracting. Here you get 5, 1, borrow 1 here. 10 minus 6 is 4. You add a 0. Can 8 get into 40? Yes. How many times? 5 times. You get 40. And your answer becomes 40 minus 40 is 0, and therefore your answer is 0.375. So 3 over 8 converted into a decimal is simply 0.375. I want to give you another one. 10 over 125. Convert 10 over 125, 10 over 125 as this C, as a decimal. Now I want to look at this very well because there's something which is going to happen here, which did not happen in our first example and second example, but it's going to happen here. So our denominator is going to be outside 105, and the numerator is going to be inside 10. We ask ourselves, can 125 get to 10? No, it cannot get 0 point, and we add a 0 there. The second question now we ask ourselves, can 125 get to 100? No, because 100 is small. We add a 0 there, and we also add a 0 there. So let us see what we are doing. We are adding a 0. If we go to the second step, we find this cannot still divide. You add a 0 both on top and in this number. So don't just add here, don't add here. That's going to be wrong. You add here, first 0 is to be added here, and the second one is to be added here. In case, in the second time, it cannot divide. Even in that time, it does not divide, you add a 0 here and a 0 below here. So now you ask yourself, can 125 divide this? Yes. How many times, Nana? 8 times. You're going to get 1,000. And so your answer is going to be 0.375. So 0.08 comes your answer. So let me do the last one before I give you work. You are going to be given convert 1/6. 1/6 as a fraction. So 6 is going to be there, 1 there. And once 6 gets to 1, no, 0 point, add 0 there. How many times? Lana? 1 time you get 6, then you get 4. Add 0. 6 gets here how many times? 6 Lana, you get that 6. So here you must know the multiplication table. 6 times 6 you get that 6. And you subtract here, you get what? You get 4 again. Put a 0 there. Then 6 gets into 40. How many times, Lana? 6. You just get 40. Lana, you can just write for me 0.166 because next one is going to be 6. But now you can tell me 0.1667. Into how many decimal places? 1, 2, 3, 4. 4 decimal places. Because 6 is going to repeat itself. You can also write just on the 1, 2. And you can write for me 0.17 to 2 decimal places. So long as you indicate how many decimal places are going to be there. So that's exactly what we are going to do in that exercise. But in case, Lana, you are given a question like this, where we begin, you can be given a question like, write as a fraction 12/10,000. Remember what we said, Lana? When you are dividing with zeros, the decimal point moves to the left. So how many times? 1, 2, 3, 4 times. You don't count the 1, you count only the zeros. So the decimal point is there. You say the decimal point, if you write 15, 15s are all numbers, so the decimal point is there. So always the decimal point of our number is to the right. Even if it's 1, the decimal point is there. So it's going to move from here 1, 2, 3, 4 times. So 1, 2, 3, 4. You write it there and put a 0 there. Where there are curves and no digits, add zeros. That is very, very important. And then write this number. 0.0012. You must write the full number. So your answer becomes 0.0012. So I'm going to give you an exercise. That is going to be an exercise, exercise 50. Exercise 50. Running from number 1 to 3. Number 1 to 3. 1 to 3. If you have understood this method, there is not use of using the equivalent method. Because sometimes it's going to give you some difficulties in getting what is to make the equivalent fraction. So number 1 to 3 on page 69. Ensure that work is done and done well. And because it's going to be a weekend, go back to the Spotlight book, do an extra work about decimals, submit to me, I'll be able to mark for you. So I want to wish you a very nice weekend ahead. Ensure that you do my work and submit for marking today, not tomorrow. Today, Friday, not tomorrow, Saturday. Have a blessed weekend ahead, and may God bless you so much.